Hi everyone. We continue video about RFM model, and now I will show you how to calculate uplift for your model. So that's the very intuitive metric to evaluate your models. Not only RFM, but any model you build, any model where you can have probability. Yes, for example, from logistic regression or some more sophisticated methods. So in previous video, I got that score, which sorts my customer in their willingness to pay to buy my products. And now I want to evaluate it. Yes, so basically I want to say how good is that score. Yes, because when you build that model, your boss will ask you, yes, how good is your model, so you can show him something. And one way to do it is to evaluate it on historical data. So in this case, I have my target variable, which is the customers' orders from real orders from October 2011. And I have score, which is calculated on the previous data, not including October. And now I can check how that algorithm sorts my customers. So to do it, yes, very convenient method is to use UPLIFT. So for that, first, I need to calculate the kind of percentiles, yes, for the score. And I say kinda because as you saw in previous video, that rank PCT true method is not exactly the percentile. Yes, so you have to to get the exact, like, statistical percentile. You have to use that formula, which I show you in Stack Overflow. Yes, you can use that link. But for my purpose, the rank PCT is okay, absolutely okay. And I will take it df score rank PCT equals true, ascending equals false, because I want to have the top, because I want to kind of find how good is top 5% of my customers by score. Ascending false, and method max. And now I have that percentile kinda, yes, and I want to split it into buckets, because I want to group my customers by that percentile, and this precision is too much for me. So I will use the buckets like this. NP, do I have, no, import numpy as np, np linspace 0 to 1, and I will take the step of it works like this. So see, now I have the kind of buckets from 0 to 1, and I want to group that score percentile into that buckets. To do that, I can use the pandas function, which is cut, and I will take here df score PCT, and here I will provide that buckets. And now see it for each score, this function calculates to which bucket it belongs. And the F, I will call it Scorecard, I will call it. Yes, and now for each customer, I have that bucket where that customer belongs. Now, I will group by that bucket, by that new variable, group by. Sorry. And I will calculate the target. Target, and here I want to have sum, like this, yeah? And I want to have it as a data frame. A reset index, yeah, cool. And I save it to lift. And now I can calculate the running total of target. Target, I will call it cum, like cum sum. Lift target cum sum. And now I will take that cum sum and divide it by the total number of orders in that data frame. So remember, the target is a number of orders in each bucket of that customers. And now I can add here one more variable. I can calculate. How many customers do I have in each bucket? Yes, so it should be equal quantity. I will just do it like that. See, count. Ag sum count. Now I have to change. I have to change my columns. See, the lift now looks like that. I have a count, and now see the number of customers in each bucket is pretty same. It's about 36. And if I take len df, yes, and divide it by 100, so I got this this number of customers. Yes. So target sum, yeah, and now I want to calculate to divide that variable for divided by the total number of orders. Target PCT, I will call it, equals. We can do like this. See, boom. Divided by, and instead of cum sum, I will use sum. Okay, lift. Now I have my table, and I want to now can calculate the uplift itself. So uplift is C. I will show you lift. Now I will take score PCT. Scorecard is in, and now, for example, I want to see at percentile 5, 10, 15, 2, 3, 4 and 4 and 5. Oh, of course, one more. Yeah. See, what is uplift? Uplift is here. I have that 13.5% here, and here I have only 0.5. Yes, so if I take top 5 customers by my score, yes, which lie in these buckets, and sorry, let me add the sum for lift count cum equals lift count cum sum. If I take top 5% of my customers by score, which is 182 customers, I will get 13.5% of all orders in that sample. Yes, so it will be among these 182 customers, there will be 145 customers with order. Yes, so that's a pretty high concentration of customers with order. Yes, so and maybe you should not make any marketing activities on that customers, because they will buy your product anyways. Now, in the next bucket, yes, I have, if I take 10% of my customers by score, which is 365, I will get 22% of all orders in that sample. Yes, and uplift is this percentage. This percentage divided by this. So, and let me check score PCT left. Score PCT apply lambda x and I will write Scorecard. Yeah, sorry. That's how I can get the right bound of that interval. Yeah, and I will add it to something here. I will call it lift score PCT. And now I can calculate that uplift. So I can calculate the I will put it here. Lift uplift equals lift score target PCT divided by lift score PCT. We should convert the date type here, and I will do it like this. S type float. It should work now. Yeah. And now see, for the top 5% of customers with a score, yes, with the highest score, I have uplift of 2.7. Means it's almost 3 times better than random. Yeah. So, and this uplift coefficient is decreasing with when I take in more and more customers with a high score. Yeah. So That's how you can compare your models then. Yes, for example, before you were asked to calculate that RFM score, your company used some other strategy to find that customers, and you can take that strategy, calculate uplift score the same way, and compare your models. Yeah, and so it's a kind of objective metric which you can compare to models. um, but in this case, yes, and in case of propensity models, uh, it's always better to perform a pilot, yes, to organize the A/B testing and test your algorithm in the field. You know, so that's how you calculate uplift score. Okay, that's it. Have fun.